blinking code. Okay, so we have one LED here, like one LED here, and we are going to toggle this LED by enabling the clock registers, peripheral clock as well as the registers. Okay. So to write a program to turn on the LED, like you should be aware of how to use pointers and how to use this bitwise operators and the hardware connection, the schematics. You should be aware of the schematics, and you should know how to read the memory map and how to read the register, how to write to a register and how to read from registers. You should know what are the registers are involved in that, and how to read the data to the register and how to write the data to the register. These are the things which you have to be aware of to program the LED. So this is the schematics. So I want you to go, or like you can go through this link. So this link will have the complete product information about the board which we are using, the nuclear board which we are using. You could also find the similar kind of detailed boards, like which if you have purchased and alternate boards or some other boards, you could find the details from here. Like this is a blog, this is the features. Okay, this is the features, and on the right hand side you could see the CAD resources. Okay, from this CAD resources you could download the schematics. Okay, only on schematics you can. So I already downloaded the schematics. So this is the schematics. Okay, so in this schematics, so it has one LED called LD2. The reference designator for the LED is LD2, which is connected to PA5. Okay, so PA5 stands for port A, and this is the 5th pin. The 5 stands for the pin, 5th pin. Okay, and A stands for port A. So PA stands for port A, and the pin number is 5. It is connected to this LED is connected to pin 5. So you can download the schematics from this link, and you could also download the other data sheets and the user manual and all those things. The next thing you have to download is the STM32 STM32F411 data sheets. Okay, this is a microcontroller which is used on the board. So this reference manual you have to download. In this reference manual, like you should be aware of you should go through this memory and bus architectures. Okay, in memory and bus architectures, there's an option called memory organization as well as memory map. Okay, so memory map contains the boundary address of all peripherals. Okay, for example, if it is Ethernet map, what is the peripheral address? For GPIO A, this is the general purpose input output A. So GPIO stands for general purpose input output. If GPIO A, this is the starting address, okay, and ending address. For GPIO B, the starting address, and this is the ending address. So this is called base address. Okay, so you can access this GPIO by using this address. Okay, so all the peripherals like the flash memory, DMA, Ethernet, USB, OTG. So all this can be accessed by using this address. Okay, so apart from this, you have the peripherals address, and you on the right hand side, on the third column, you also have the bus interface. Okay, if you check the GPIO A, it is connected to AHB1. So all these peripherals are connected to this base address. So AHB stands for Advanced High Performance Bus, and APP stands for Advanced Peripheral Bus. Okay, so peripherals like SPI, SPI, USART, and timers are connected to the peripheral bus, whereas GPIO is connected to AHB1. So you could access this bus by using this address. Okay, by using this base address. If you want to access GPIO A, then you could use this base address to access this GPIO A. Okay, so you should be familiar with going with this memory map registers, and you should use pointers to use this address for example, to enable this GPIO A mode registers, you could use these pointers. Okay, so you just take a note of this GPIO. It is 0x4002 0000. Okay, so this is the base address, and you need to enable the peripheral clock. So you find on the data sheet, you find reset and clock control of RCC. Okay, you go for RCC registers. In RCC registers, you just search for the peripheral clock enable register. Okay, you have to search for peripheral clock enable. So you just scroll down, like this is peripheral reset register. Okay, you have to find out peripheral clock enable, peripheral reset register. Okay, so you just find out this peripheral. Okay, peripheral enable register, peripheral reset. This is peripheral reset register. Okay, so this is what, this is the one, peripheral clock enable register. Okay, in this register you have to enable this GPIO. Okay, and the address offset is 0x30. Okay, so the address offset is 0x30. So you have to calculate the base address of RCC, and you need to add this offset address to reach out this enable peripheral clock enable register. So I just copy this value and I just keep it on a okay. So I just copy this value, like, and I will keep it on a notepad. Okay. Okay, so this is the address offset value. Okay, so if you find out the, if you find on the memory map, if you find out the RCC register, you could find out the base address for the RCC. Okay, so this is the base address. The base address is RCC of this is here. Okay, so this is the base address, and this is the offset address. So base address is 3800. Okay, so this is the first thing. First thing is to find out the base address of this RCC and the address offset for the peripheral clock enabled register. Okay, once you have done this, then you just go for the mode register. You need to find out the GPIO port mode register. Okay, you just go for general purpose output. So you just click this registers here and click mode register. The mode register, we have 4 different modes. It can be used as the input mode, or it can be used as output mode, or you could have alternate function mode or analog mode. Okay, so we are going to use general purpose output mode. So we need to use 01. Okay, so this is the offset address. Address offset is 00. Okay, so GPIO port mode register, like so we have to use this 01. Okay, 01, and like it has 32 bits. So we are connected to 5th pin. Okay, 5th pin. So this is 0, 1, 2, 3, 4, 5th. So this pin we need to set as 01. Okay, this mode 5, because it is connected for us, the LED is connected to PA5. The 5 stands for the pin 5. So in this pin we have to set as 01. So that will be enabled. This is in mode register that will enable general purpose output mode. Okay, so the next thing is to find out the data register, output data register. So you search for the output data register. Here it is 16 bits. Okay, from 0 to 15. So in this we need to write 1 to this 5th pin. Okay, because the 5th pin is connected to the LED, so we have to write 5th pin. So only three steps. The first pin enable the peripheral clock, the second pin enable the mode register, and second step enable the mode register, and third step write the data to the output data register. Okay, so only 3 steps you have to do. Let me open the software and let me show that. Okay, so I just type STM32Q by DE. Okay. So date and target. Okay, I'm just copy the path. I'm going to use the same path here. Click launch. Close this window, file, go for new STM32 project. Okay, under board selector, you have to choose Nucleo F411RE. Okay. I choose this board, click next. I just type as LED blinking. Choose this as empty, click finish. Okay. Okay. So without writing the code, let me show the output first. I just remove this one. Okay. Right click, build this project. And I'm going to download this debug as create a debug configuration. Okay. Choose this serial by viewer. Okay. Click apply, click debug. So I'm going to blink the LED just by directly giving the register value. Okay. Switch. I'll go for the debug mode. Okay. So I go for window and choose this. Choose the show view as SFRs. Okay, special function registers. So it will list down all the registers. It will list down all these registers. So we need to choose the RCC register. Okay, just go for RCC. In RCC, like AHB1ENR. Okay, AHB1ENR. So this is GPIO AEN. This is the one which we need to enable here. Okay, I just enable this pin. Now I have enabled this directly by clicking here. I have entered into the debug mode. So currently we have the downloaded the empty program. So you could directly blink the LED by setting the registers here. So first I have enabled on the RCC register. Okay, on the RCC registers, like I have enabled this. I have go for AHB1ENR. Okay, advanced high performance bus ENR registers, enable registers. All these are reset registers. You have to go for ENR. In ENR, LED is connected to GPIO-A. So I have choose this GPIO-A and I have toggled this first. Okay, so GPIO-A has been enabled now. Now I just go for the GPIO-A. Okay, click GPIO-A. So here you could also find the base address. Okay, RCC, like you could also find the AHB1ENR. Okay, so you could find the base address. Okay, 30. you could find this base address. Okay, this find this base address is 40023830. Now let me check for the mode registers, GPIO. In mode registers, the first thing you have to do is you have to set up on mode 5, you have to set up 01. This should be 1. Okay, I toggle to make it as 1. I have set up this. Now I have configured this as output. 01 stands for, like in the data sheet, like the output, like you just go for the mode registers. Okay, click GPIO mode register. You have 01. You have to give 01 at this point at mode 5, mode 501. Okay, so mode 5, I have given mode 501. Okay, it has changed now. And now I have to click the output data register. This is the output data register. So we are connected to 5th, this one. Okay, 5th one. Now, if you see this output, let me expand. Okay, here is the LED. Like I'm going to toggle this as 1. Okay, you could see I'm toggling this. Okay, so you could check now. See, I'm toggling, so the LED is blinking. Okay, so you only want to give, like, it said 3 registers. One is the RCC register for peripheral. You have to enable the peripheral clock. The second is the mode registers. You have to configure the GPIO and then output data registers. Okay, so this is the output data register. Like we have just enabled it. Okay, so if you do this, if you configure these 3 things, then you could write the program for the LED. Okay, so for this output data registers, this output data register, you could so I just declare like 3 variables here, like uint, okay, uint32 underscore t. Like I just declare a pointer variable called output data registers, ODR. Okay, here it is ODR. So ODR equals so I have typecast this. Okay, so that's a base address 400200014. Okay, so that is a base address. I'll show you how to calculate this one from data sheets, but as of now I am taking from here. This is the base address. Okay, I just copy this, paste this, and I click this mode registers. Okay, mode R. Okay, so mode R is this base. This is the base address 04 for mode R. That is the base address 04. Okay, this is the base address. Okay, then you have to give the RCC, the value of the RCC register. AH, this is the one. Okay, AHB1 ENR is 2830. So it is AH AHB1 ENR, it is 3830. Okay, 3830. Let me enable this. Go for preferences, go for appearance, colors and fonts, C++. Okay, click editor window, text and font, it's 20. Okay, click apply, click OK. Okay, So we have configured this. Okay, right click, build this project. Okay, so now we have to set the value for the AH. Okay, you have to choose this. Okay, you have to R1, because to set GPIO, to enable the clock for GPIO, to enable the clock for GPIO, like you need to R it by 1. Okay, and then like you need to, for mode or register, like for this, first you need to clear. For clearing, you have to use the AND operation with the value 0x. Okay, f of, I will tell you how to calculate this value, f of 3ff. Okay, and then you have to calculate, you have to, or you have to set. First clear, then you have to set. Okay, you have to set. Then you have to set this ODR register. Sorry. Okay. So now build this project. Build this project. Let me check. So it has been switched to debug mode. Okay, the compiler has been, the ID has been switched to debug mode. So AHB1 ENR, like we have this value, like this is the address. Okay, I'm going to go for step-by-step execution. Like if you check the value of this AH, let me go for window, show view. Let me check the SFRs. Okay, on this SF4 registers, I will check for the RCC. Let me check for RCC. The RCC register, like AB1 ENR. Okay, here on the, we have to enable this GPIO. We have to enable this one. Okay, so let me keep a breakpoint here, and I just click step-by-step execution, step into. Okay, step into. Let me click the debug mode again. Switch for debug perspective. So I just click step. Okay. So before I execute, like let me go for window, show view. Let me open the SFRs. The RCC register. So this AHB1 ENR. Okay, here we have to enable this GPIO. So go for step. Okay. Okay, if you check now on the right hand side, you could see GPIO AEN. Okay, this has been enabled now. So we have enabled the peripheral clock. So the next thing is we need to set the mode register for the output. So there are 4 modes. One is the input mode, output mode, and the analog mode. Okay, and the functional mode, like we need to put 0, 1. So click mode registers on the GPIO. Okay, this is GPIO A. In GPIO A, click mode register. In mode, we have to set this one. Okay, we have to, this is the one which we have. So mode R5 we need to set. We need to set this R5. So I click step into, okay, and if I check now, it has been set. Okay, we have set the mode register as 0, 1. Okay, the mode register we have set as 0, 1. The next is the output data register. The output data register is on the GPIO, it is ODR. Okay, ODR, we have to set this 5th one. Okay, we have to set this 5th one. Let us check now. So if you see this, if you check this, the LED is off now, currently in off condition. Let me go for step execution. Click step. You could see the LED is blinking. Okay. So to blink the LED, like you have to get this AHP IENR registers, enable the peripheral clock, and configure the mode, GPIO mode and ODR. So in order to get this value, you can open the data sheet, click for the memory map, copy the value from here. Okay, for example, the RCC, this is the base address. Okay, RCC, this is the base address. So you copy, like this is the base address. If you want to take the value from the data sheet, this is the base address. Okay, and you just go for the RCC. Okay, RCC register. In RCC registers, you click the RCC registers, you just go for the AHB1 ENR register, enable registers. Okay, the address offset is 30. Okay, the address offset is 30. So the address offset is 30. Sorry, it is 30. Okay, so if you add this 2 thing, okay, if you add this 2 thing, you will get this. You will get this address. Okay, the base address plus the offset. Now let us check for this mode register. Okay, I just go for the data sheet. I click for the memory map. The GPIO A is the base address. This is the base address. Okay, I just copy the base address from here. I just copy the base address. This is the base address. Okay, and I just go for the data sheet again and click for the GPIO registers. Okay, GPIO registers is mode, first mode register. The offset is 0. The address offset is 0. So you could directly, if okay, is 0. So you could directly use this address here. Okay, for ODR, let us check for the output data registers. For output data register, the base address is this one. Okay, this is the base address, and for the output data register, you search for this one. Okay, offset is 14. The address offset is 14. Okay, address offset is 14. So if you add this value to this address, you will get this one. Okay, if you add this offset value here to this address, you will get this value. Okay, so we first thing, you need to assign a pointer for this. So you have to typecast it as a pointer. Tell the compiler this is a pointer address. So assign the pointer address, and you need to, we are setting this value 0, 1 to the enabled registers. This value 0, 1, the reason we put 1, because you just go for the RCC register, like RCC register. In RCC registers, like go for enable EN1. Okay. Okay, you have to choose the right one. ENR, okay. AHPV, peripheral clock enabled register. So here in this register, offset is 30. So the GPIO-A to enable here, to enable, because it is connected, our LED is connected to GPIO-A. So in order to enable this one, you have to enable 1. The rest of the value is, you should not do anything, rest of the value. So just set 1 and you set the bit R. When you bit R this with 1, so that will enable the last one, GPIO-A. Okay. And this is for mode R, like for setting the mode R register. Like you just click you just go for the mode R registers. Go for GPIO. Okay. In this GPIO registers, the first is the mode R registers. Okay. Here we are connected to the GPIO A and it is 5th pin. Okay, PA5. So this is the 0th pin, this is the 1st pin, 2nd pin, 3rd pin, 4th pin, 5th pin. So here you have to set 0, 1. So here you have to set 0, 1. The rest of the place, everything will be 0, 1, will be 1. Okay. So first, in order to set 0, 1, first you need to clear this 0, 0. So in order to clear this 0, 0, first clear this 2 bits. So for clearing, you should use bit end operation. For setting, you should use bit R operation. So you put 0, 0 here to clear. So 0, 0, the rest of all FF. So this will give you 4, 0. This will give you this value. Okay. FF, all the 4F will be F3FF. Okay. If you check here, here it's 1, 1, 1. So F again, 1, 1 F. Okay, F. So 4F on the top. Here 1F. Okay, but here it is 0, 1 and 0, 0. Sorry, 0, 1 and 1, 1. So 0, 1 and 1, 1. 0, 1 is 0, 1 and this is 1, 1. So 1. 4 to 1, 4 to 1, 4. So it is 3. Okay, it is 3 and it is FF. First it is 0, 0. For first it is to set this, clear this, it is 0, 0. It is not 0, 1. First you need to put 0, 0 to clear this one, 0, 0. And 1, 1, so that is 3. Here 3 and FF. So this value. Okay. So 3 FF. This is to clear, and then you have to set. To set that bit 0, 1, it's 400. Okay. You convert this to binary and load that value. You will get it. You will get the point. Okay. And this is to trigger the output data register. The output data registers, again, you just go for the output data register. GPIO registers, just click GPIO registers. You go for the output data registers. Okay, output data register. Here we need to enable the 5th pin. Okay, you put 1 here, the rest all 0. So you will get 1. This rest all 0. So you will get 2, 0. Okay, so 2 hex value of 2, 0. You bit R with hex value of 2, 0. So that will blink, that will on the LED. Okay, so this is the code. Hope it understands. Okay. So today's session, like we have covered up the registers. We have covered up the memory map, and we have covered up the registers for the RCC register, for the clock enabled registers, and mode registers for GPIO mode registers, and output data registers. Only these three registers you have to configure. So you, for this to implement this, you should be aware of the pointers and bit or operation, and like bit and bit or operation, okay, and to toggle the LED.